Well, good afternoon, everyone. I'm very excited, as always, to be back for another episode of the Industrial Real Estate Show. We're doing it on Wednesday today because I just got back from Dallas. I was there for the SIOR conference, and it was a terrific conference. Learned a lot of things. Put some of those into the newsletter that I sent out on Monday as well. So if you're not subscribed to that, go to industrialinsiders.com and you'll follow along with all the news that I'm covering on a day-to-day basis. I do a weekly digest, so I'd encourage you to go check that out. Put some interesting things in from what I learned at the conference this past week. That was in there as well. So a lot of information to take in. And this guest that I have coming on right away is very fascinating to me because I love the idea of changing buildings which might have some functional obsolescence in the form of lower ceiling heights. I've talked about it extensively on my channel that low ceiling heights can often be the difference between a company taking that building or not taking that building and going to a property that does have higher ceiling heights. So Marty is his company works all across North America in essentially lifting the roof of a warehouse space and not only increasing the cubic footage of a building that otherwise might not be able to accommodate a tenant's demands, but it just increases the clear ceiling height. So you can have more racking in there. You can have more storage in there. There's a lot of benefits for that. And I'm sure everybody that's listening to this would understand that a building with higher ceiling heights, all things being equal, will be more valuable than a building with lower ceiling heights. So we're just going to jump right into the meat of this and talk about the process, some of the costs that can be expected, some of the timelines, and really just get Marty's insight and his experience on how he's doing this and some of the situations where it works. So very pleased to be joined by Marty. Marty, thanks again so much for joining me on the call.
Excellent. Thanks for having me.
So I guess the biggest question that I would have is what buildings are suitable to have the roofs lifted and which buildings are not compatible to have the roofs lifted?
Okay. First off, what I tell people right off the bat, Chad, is most people have never done anything like this. So
Yep.
the process sounds pretty daunting. The more we go through it, the simpler it becomes. But definitely no such thing as a bad question. So keep that in mind. In terms of which buildings makes the most sense, it really comes down to the dollars and cents of the whole process because we've lifted one bay of a building for a piece of equipment, and we've lifted up to 700,000 square feet of a building. So every building has its own little idiosyncrasies and things that make it either a great candidate. These things either really make sense or questionable, or there's sometimes just better alternatives, or the certain rents costs don't justify the ROI to the whole process. But we've lifted pre-engineered buildings. We've lifted typical CMU load-bearing, concrete block wall buildings. We've lifted concrete columns, concrete decks, wood buildings, tilt-up buildings, pretty much everything. The only thing that present a cost challenge are the old barrel-style roofs on the West Coast because there's a lot of wood framing, and the cost to retrofit those and bring those up to code just sometimes is not cost effective. So pretty much we've lifted all types of buildings. So there really isn't one that makes more sense than others. It really comes down to how much of the building are we actually reusing and being able to lift versus does it make sense to sell? What are we salvaging?
Yeah, and that's a great transition into the process itself because I'm very curious how that actually looks. So I'm sure, like you mentioned, depending on the construction, there'll be some different techniques that you incorporate, I'm sure. But what is the general process of lifting a warehouse roof?
Yeah, it's basically a synchronized hydraulic lifting system. So what we do is we set up a series of crib posts, which are hydraulic lifting towers. Depending on the weight of each individual column in the building, we'll set up either 1, 2, or 4 of these lifting towers beside each column. Around the perimeter, we can set them up under the existing steel structure. We would introduce temporary lifting beams if we can't get to the underside of a perimeter of a building. So that's part of our engineering, our means and methods. We would lay out basically how we would set up these lifting towers. They would get bolted to the floor. They would get welded to the existing steel. They would get synchronized to our central control panels. So what that does is once all these things are installed, they get pressurized, which in essence takes all the load that's off the perimeter walls, off the columns of the building, transfers it to our lifting system. At that time, columns get cut, mechanical, electrical, plumbing, sprinklers, perimeter roofing, all that would get cut to allow the roof to go up. Um, Roof would go up probably 6 to 12 inches an hour, averaging about 4 to 5 feet a day. And at that point, the new steel, either stub columns, full height columns, whatever the new structural design entails, would get installed. We take our system down and we're done.
It's pretty crazy. I think people would underestimate how much work is involved just in even separating the roof from the envelope itself, and then sprinkler heads, HVAC, electrical, all those are either running with the existing roof or part of that system. So having to separate all that certainly takes coordination. Do you
It does.
general contract all of that? So do you have like the plumber and the electrician coming in, or do you guys do that all under your umbrella?
Rooflifters is a subcontractor that actually does the lifting itself. So those are our guys, travel the country, been doing it for 30 years, and they are the only ones that will actually set up and actually lift the building. All the other work is local subcontractors. So we have 30 years of general contracting experience, 30 years of lifting. We can come on just as the sub, regardless. We're involved, from day one. So once we get hired, just as let's say as the lifting contractor, we almost become an owner's rep role to make sure that, because it's very important to us that these things get done as cost and time effective as possible, so that people will repeat the process, and if we use a project as a reference, it needs to go well, it needs to be cost effective. So it's very important for us to stay involved the whole way, whether we're just the subcontractor or taking on the general contracting role. If we are asked to take on the general contracting role, what we'll usually do is we will engage local GCs that we've worked with across the country over the years. We will negotiate with an owner, developer, basically a cost plus percentage that they're going to be building in on any of the sub trade work. And then from that point, everything is all open book construction management type of setup. So it's a combination of our trades, owners' trades, GC's trades, people that are working in the existing building. It's basically a collective effort to get these things done as smart and value engineered and cost effective as possible.
What does the process typically take time-wise from, the time that you're on site, to it being raised and then closed back up and the connections restored?
Depends on size.
Mhm.
So on the smaller buildings, it could be as quick as 2 months, let's say 8 weeks. And then on the bigger sizes, it really depends. It could stretch out as long as 6 months on a 400,000 or 500,000 square foot building. So
What
there's buildings vary based on the amount of columns. Is it a
Yep.
25 by 25 column space building that's going to require a lot more steel work, setups, etc.? Are they 40 by 40 bays? Is it a pre-engineered building? So the timelines vary a little bit based on the size of the buildings and the little nuances of that particular building, plus any other work that's involved. Are they cutting in new loading docks? Are we eliminating kind of load bearing demising walls, and replacing those with columns and footings to create like one big vast open space? Are we taking out every second column to create a bigger bay size? So those are all different little things that would tweak that timeline. But basically, how the projects unfold is we'll get an inquiry. Someone will either send it in online, our form, or call us. In 5-10 minutes, I can go through the whole building. Does it need new roof? Does it need new sprinkler system? What's the additional lighting, HVAC, things like that? Come up with a high level number. Present it to the client to see if that's anywhere near penciling, and
Mhm.
just keep the process going as it continues to make sense.
So if I were to give you a hypothetical situation, could you give me some ballpark pricing on it?
Yeah, absolutely.
So let's say it's a 40,000 square foot industrial building, concrete block, let's say 20-foot ceilings, sprinklered, run traditionally as you'd expect with HVAC and electrical and lighting. No dated. Let's say it's a vintage 80s building. So dated, but still functional, sprinklered, normal HVAC lighting, everything there. And call it just a normal box. A third of it built out as office, two-thirds of it built out as warehouse, same ceiling height the whole way through. What do you
Right.
think and I'm sure that there's a cost difference between increasing that, let's say it's 20 feet, increasing it to 24 versus increasing it to 28. I'm sure that there's obviously a cost, but could you break down how that would look in that hypothetical example?
Yeah. So I would say on that, okay, let's go to, let's call it 28 feet, because the difference between 24 and 28, the difference on the lift only number, which is us as a sub, isn't that substantial, because it's just an extra 4 feet of lift, a few extra days setup, tear down equipment. So that's not such a big spread. But there would be a spread on the additional 4 feet of steel,
Mhm.
because you're going 20 to 24, you might be able just to get away with a 4 foot stub column, okay,
Yep.
attached to the existing one. Whereas if you go to 28 feet, the existing columns may be too slender. So you might have to replace much more of that column. So at that point, it becomes really an engineering, analysis as to, what that, break even or sweet spot would be in terms of existing conditions. But I would probably, what about the condition of the roof, Chad?
Well, vintage 80s, so call it a 30 years, so the deck
Okay, so
should be
new.
in pretty good shape and, call it the roof was replaced halfway through, so maybe 20 years left on the tar and gravel.
Okay, so I'd say between the roof lift, steel, and enclosure, 20 to 28 feet, somewhere in the $20 to $25 square foot range.
Hmm,
And then depending on if you're able to, if the sprinkler system, the lighting, if these things work up at the higher height, then all you're doing is cutting them, raising them, and reconnecting them with either a junction box or riser pipe. So those costs are pretty minimal. If you did need to replace that with a brand new ESFR sprinkler system, then you're going to add another, probably $5. A new lighting pack would be another dollars. Um, New roof, depending on the condition. So these are all things that are a little more building specific that we can go through with an owner, um, on the specifics of that building. But I would say I would tell someone to probably budget all in everything that they're going to need to do their wall bracing, perimeter roofing work, sprinkler modifications, lights, probably 35, $40 a square foot. So, call it 1.5 million, somewhere in there. And then if that's anywhere near making sense, then I'll ask them to send us in a questionnaire that I'll send out, and send us back any drawings, pictures, anything they have on the building. We will work out a hard number on the lift itself, because that's just going to be for us the function of how many columns there are in the building, how long we think we'll be on site. And then with my in-house quantity surveyor and engineer, we will come up with a pretty tight budget number based on the steel that we feel will be required, as well as we'll carry an infill number. So the difference, the 8 foot high lift plus, multiplied by the perimeter, we'll carry an infill allowance, for that. See where that's coming in based on our original discussions. And again, they'll just keep going as they continue to pencil.
and you said the timelines can vary as well, but for a building of that size, I'm guessing you're closer to, like, the smaller ones you've done versus the 700,000 square foot one that you've done. What would you expect on timelines for that?
40,000 square feet, you could probably knock off in, I'd call it 10 to 12 weeks.
And during that process, I'm assuming you can't do anything in that building. It's exposed to the elements. There's construction crews working there. You essentially would need that building vacant for that period, I'm guessing.
Not necessarily. I mean, I mean, number one, if there is an existing tenant, so we do a lot of build work with tenants in buildings. So we can either do it in phases where they can work in half the building, we lift half, they move into that other half, and we lift the other half and match it all up. Or while we're setting up, so of that, call it 10, 12 weeks, probably 4 weeks is set up. So in that time frame, as long as people are following OSHA rules, hard hat, safety boots, all that stuff, a lot of other GC work would be happening at that time. So any of the rough-ins, any of that work, again, as contractors ourselves, we're involved in trying to obviously condense the schedule, not just with our work, but with all the other work as well. So there is some work that can happen at the same time. But again, once you open that up to the elements, depending on the time of year, so if you're opening this building up in the middle of winter and you're trying to keep half of the building occupied, there's a sprinkler system that has to stay warm enough, dry enough, so that everything's doable. It's just a question of what those additional winter heat costs, or tarping, or global wrap, or some of those things to keep everything dry.
Yeah, that's a good point. I'm glad you talked about that because the timing would be imperative in doing this. If I was in Dallas last week and it was 30 degrees, so I don't think they're going to have the same problem that you have in Toronto. But that's a good point because I'm guessing if you're not tarping it off and paying the additional cost to heat all that area, you've got to drain and flush those systems. Otherwise, you run the risk of those pipes all freezing. So I led to the next thought I had on this is you've got to be incorporating a lot of different people to have a process like this go off. It's not just so simple as putting the hydraulic lifts on and lifting it up. You're coordinating between a number of different stakeholders in the process. The property owner, the tenant has to be involved. What do you need involved from a municipality or permitting standpoint to go and do this? Is it just as simple as a normal development permit?
Even more simple, and that's what's driving a lot of these projects. As long as you stay within allowable zoning heights,
Mhm.
and you're not adding any gross floor area to these projects, or the mezzanine, you might add a small mezzanine that's allowable based on the percentage. These fall under renovations. So
Mm.
no site plan, no water retention, none of the issues that come up, no development charges, none of that stuff applies with a roof lift. So the building, pretty much the structure, is grandfathered. Okay, so if the existing roof framing, roof insulation, all that isn't as per current code, it's all grandfathered. You do not have to change that. Any of the new steel work, obviously under the sprinkler system, that would be obviously have to, those are life safety issues and things that would have to be as per code. But one of the biggest drivers now is we can turn a permit around. We've had a permit in some areas in as quick as 2 days because the
Wow.
building's been sitting empty for years and they just want someone to start working on it. And in some of the harder places, West Coast, some of the bigger cities, it might be as much as 2 to 3 months. So it's not a year and a half entitlement process like it would be with a new build. And one of the big factors with this is, if there's really three options. You can lift this existing roof, okay, which is a renovation. You can tear off the roof, okay, try and reuse all the structure and rebuild it at the higher height, which we don't recommend because, number one, that's going to trigger new construction in a lot of municipalities. And then trying to reuse an old joists that have been cut away from metal decking and things like that, chances are you're going to compromise them and you won't be able to reuse them. Or the third option is knocking that building down. So once you knock that 40,000 square foot building down, now from the 80s, the zoning's changed. So you have different side yard setbacks. You have different, so you might not be able to get the same footprint that you had before. So that's why it is still a site specific exercise. But there's real time constraint. There's real time savings on lifting this versus most of the other options.
Well, and like you said, with that example that we were going through, if it's $1 million, give or take, if you can take a building that has that functionally obsolete ceiling height of 20 feet. And there's still a lot of tenants out there that will still take 20 feet, but there are some tenants
Yes.
that are demanding 28 plus right now. If you can take a building like that, increase the ceiling height without having to reconstruct, go through major renovations and planning, and you just physically raise the roof, you're all of a sudden opening that building up to a whole new market that otherwise wouldn't have even considered it. I guess that's the question. From your experience with all the different projects that you've worked on, is this usually a tenant-led initiative, or is it the property owner initiative, or is it just someone that's trying to future-proof the building? What's the typical demographic of your customers?
Yeah, it's a great question. So initially, these projects were happening for owner users. Okay, they were in a space. They knew that they were, slammed, maxed out on space. What are we going to do? So that was to move there a facility, finding the facility, um, building it all out, making sure you're close to the existing one so you can maintain your labor force. All that were big factors in owner users wanting to, that took on a lot of these projects. Now what's happened over the last, few years, there's a significant delta in the rents, okay, or lease rates between a 14 or 16 or 18-foot high building versus a 28 or 32-foot high building. That spread wasn't as big at one point. So if there was a 50-cent difference, between a 16 and 28-foot high building, it's probably not going to justify spending, 20 or $30 to retrofit that. Now the spread and the delta between those two options, the lower height and higher, is that spread's become pretty significant, and in some markets very significant to justify that. So that's led to a lot of developers, buying these buildings. They either have them in as part of their existing assets that they have at a low enough basis to justify spending the money. So that's opened up to a lot of developers. And also what we're seeing is so that's on the industrial side. And what it's also done in there's so many of these empty retail stores, the Sears, the Sports Authorities, all those, Kmart. So we're also repositioning a lot of those retail buildings to either new retail, or entertainment use, urban air facilities, trampoline, rock climbing, new movie theaters, things like that. And another big spinoff has been developers repositioning some of these older retail and industrial buildings and converting them to 2 and 3 story self-storage. So they'll take an existing 18-foot high facility. It'll need, let's say, a minimum of 22 or 33 feet for a 2 or 3 story facility, and they'll raise it accordingly and put a 2 or 3 story system inside there. So initially started as owner users, and now it's much, over the last few years, really opened up to making sense on the developer side. And a lot of developers are doing it. A lot smarter guys than me that are pulling the trigger on these things. So obviously the dollars are making sense.
Yeah, I can think of one example actually that this would have been very useful for, and it goes back about 10 years now. It was a building that I was marketing. It was roughly a 20,000 square foot industrial building on a couple of acres, and it was purpose built for the owner of the building also owned the company that was occupying, and he purposely built it for that company. And they had no desire or no need for high ceiling heights. So they actually built it at 14 feet, like 14 feet to the deck. So if you actually took the clear height, it was closer to 12 feet. And they did that because they had no need whatsoever for higher ceiling height. And they just figured they'd cut down on the cost of heating and cooling that much cubic footage if they had lower ceiling heights. And when he went to sell it, because he had purpose built it for his company, he didn't think of that, what happens when he needs to exit that. Almost everybody looked past it. They wouldn't even consider the property because the ceiling heights weren't functional for the vast 99% of the market. And had he considered the potential of just increasing that roof, it was a gorgeous building. It was very well done because he built it for his own company. So very nice building, good site coverage, good area. The one limiting factor which caused it to sell at a massive discount was the ceiling height. So I think either the company or perhaps a developer or an investor can see that, and if perhaps they're looking at ceiling height buildings with lower ceiling heights, and they can say, well, might not be the problem that we think it is if you can actually engineer it and spec it out on the cost and what it would take to rectify that. Then all of a sudden you're looking at it as just a problem that you can solve versus a problem that you just pass on. So yeah, I think you probably are starting to see more from the owner users that says, well, if we can get an extra 8 feet, we can get an extra rack of storage in there. Now you're seeing people that are looking at it to say, we can just solve this problem.
Right. And we'll get involved early with our, racking engineer so that we can basically help them figure out what additional pallet positions, they would get from a 4 foot versus an 8 foot lift versus a 12 foot. So they can actually really try and substantiate those costs. But these days, again, with the timing of new versus, at one time you could put up a building for, call it $60 a square foot, and
Mhm.
to redo, and our process was, call it 20 or 25. So the spread wasn't as big if someone really wanted to build a building that they wanted perfectly suited for themselves. The 50 by 50 column spacing, the 120-foot truck courts, all those new criteria for the new builds. But now the spread between our process and building new, and the availability of things like joists and deck and roof insulation and switch gear and all that stuff. So the spread just keeps getting bigger and bigger. And going back to your point, Chad, those buildings that were built 14, 16 feet, people were usually manufacturing out of them. So you didn't need to be higher than that. The racking systems only went so high. The forklifts only went so high. People weren't even thinking about, racking up to 28, 32, 40 feet at that time. It just wasn't, it wasn't really, there was very few buildings that were built in that era at that height.
Yeah, that's a very good point, and that those are prime candidates. Those buildings in the early '80s vintage or pre-'80s. There's a lot of buildings in urban areas that were built in the '60s, and like you said, there are those manufacturing properties that didn't take that into account. So I think what's very promising about this, I'm very glad that you came on the show because I had no idea that this was a possibility and an economically viable possibility. But
Right.
I'm sure like
That's
everybody
our
that
biggest challenge. That's been our biggest challenge for years. That people don't even know that this is an option. We've done a really good job in educating people, and plus with Google, you can search up that stuff. But that has been our biggest problem, for years. Is we still run into huge developers and owners that didn't even know that this was an option.
Yeah, well, and I'd fall into that camp. I would assume that anything is possible. Like you could do anything you want in construction, but I just would have thought it would have been so prohibitively expensive that you'd just go and either move on to another project or just adapt to the situation you have. So I think it's very encouraging that you guys are doing it at a rate that justifies it economically. I just did see that a question came in. So if you've got a few minutes
Sure.
still, Marty, can we take the question?
Yeah. No. Absolutely.
And
Yeah.
just before we get to Yakov's question, I saw Beverly joined in, so just wanted to say hi to Beverly as well. Uh, thanks for joining in, Beverly. Yakov, thanks for joining in. What a great topic. I completely agree. How sensitive are these roof raising projects to material price fluctuations? What are the main materials other than steel? Great question, Yakov.
Mostly steel.
Is it
So
mostly
really,
steel?
it's because the sprinkler system would be mostly steel, and any of the additional steel that's going to be required to get at the newer height, as well as the perimeter is usually just a corrugated metal or an insulated metal panel. So we are a little bit, of course, we're at the whim of the price of steel. Um, that's pretty much about it. And again, the actual the steel that we're putting into these buildings are very basic beams, columns. So the fabrication, the cost in the fabrication hasn't gone crazy over the years. It's in the supply. So that component, although it has added cost to it, not a huge difference. And steel prices have come down a little bit too, and I think are leveling off. But majority of the projects really are, and our prices really only fluctuate based on shipping costs going up, insurance rates, um, the basic things that are being affected, let's say by inflation. But For the most part, it's just the biggest variable is in the price of steel. And we're not buying massive amounts of steel for a lot of these projects because they're just columns and beams. The decking is existing, the joists are existing, all the existing beams are there. So a lot of it is, we're basically recycling old buildings, and the objective is to reuse, as much as possible.
Speaking of the perimeter construction, is it the same? Do you do the same perimeter? So that called that top 8 feet, is it the same material that you use irrespective of what the original building material was? So if it was concrete block or pre-engineered steel, are you using that corrugated steel regardless of what that original construction was?
Well, the original construction is probably, you're only allowed to take that up so high, right?
Yeah.
Block, unsupported block. And there's different, structural factors on what you can actually take up farther than, where it is now. So ideally, if it's a 3 or 4 foot lift, we'd like to continue up with the existing masonry, okay,
Mhm.
because that just simplifies it. But otherwise, there's the least expensive, on top of those typical CMU or tilt up walls, or pre-engineered, or precast, would be just corrugated metal with insulation. That would be the
Mhm.
least expensive. From there, it would be corrugated metal, insulation, and interior liner. From there, the next step up would be an insulated metal panel, like a Kingspan panel or frost. And then from there, you could do stucco, you could do curtain wall. It's really just, and a lot of times what we'll do is we'll put something a little bit nicer on the facade that is visible to the street or to the highways, and then something, much less expensive on the other, 2 or 3 sides. So it really just depends on budget and the aesthetics that the client's looking for.
Yeah, well, that makes sense. Follow-up question from Yakov. Are there attributes of old buildings that would make them ineligible for this kind of project?
No, not that wouldn't make them ineligible. It would just be whether do we need another line item? What is the thickness of the slab? For example, if you've got a 3-inch slab and you go into 40 feet, you're going to have to factor something in for, a new slab. Um, the nothing that would make it ineligible. It's just a question of whether we add in a line item for the additional work, and if
Yeah,
it's
because
still
I'm
going to make
guessing.
sense once you add a $7 to $10 square foot for a new slab.
Yeah, because even those, like, I call it that one building as an example that I share with a 20,000 square foot with the 14-foot ceiling heights, that just wouldn't have been engineered to hold the additional weight that would come, I suppose, by adding it. So would you have to replace the whole slab? Would you have to replace columns to make them larger columns? What would be the process of taking, like, a really old industrial building that had, a really low ceiling heights? Is it that extra line item, I guess, is what I'm trying to flush out. What does that extra line item look like from a cost standpoint?
The numbers I gave you would factor in new columns. So what we do is we
Okay.
cut the columns just above the slab, slide a base plate over that existing stub that we've cut, and then put a brand new column right on top of that, so that all majority of the work stays above the slab. In terms of some of those older buildings were built, you know, the slabs are a lot thicker. It was only after, a certain year where people were trying to build them as inexpensive as possible. But a lot of these older buildings certainly have sufficient slabs to rack them to the newer heights. And in a lot of cases, if they don't, we'll put a topping. So you can either put a 2-inch topping, on one of them, on top of those. Part of the initial process would be to do, some core samples and expose a couple of foundations to know what you're dealing with before we got, too far into the project, to see whether it's going to require a slab, just a topping, or whether the existing one is sufficient. And depending on what the next use is, whether if it's for an existing owner, then even if it's a thinner slab, you can get by with bigger base plates, on your racking. You can do spreader beams across your racking. So there's different things that can be done with the racking system that will allow you to stay with the existing slabs too. But that's where it becomes a building by building, specific cost.
Yeah, and I do want to leave a little minute at the end here to direct people to you so that they can get in touch with you. So as a segue into that, I know you've worked in a number of different markets in North America. Is there any markets that you won't work in North America, or is it pretty broad?
We've gone as far as a lot. I mean, we've gone overseas, Alaska. No, there's no really a market that it's just a question. The markets that make the most sense are obviously where the economics, the vacancy rates are very low. A lot of the, these existing buildings are, kind of urban, close to the old rail, close to old highways. The newer, the places out that have lots of land that are building million square footers, 5 miles out of the city where there's still not huge traffic. Those areas aren't as don't make as much sense. But it's really all these old stock, New Jersey, New York, Long Island, Massachusetts, Carolinas, California, Chicago. Now at one point it was really only 3 or 4 major cities, whereas now it's really making sense in a lot more places.
Yeah, I think you are onto something. I think as more and more people hear the message that this is something that can be done relatively affordable, I think it's going to be a great option for people that are seeing opportunities where that ceiling height is a literal limitation, and they'll see a way to fix it. So I've got your website and your LinkedIn in the description. You've got a lot of videos on there as well, showing like some of the before and afters and the process going through it. And I might add, you've also got one of the coolest logos that I've ever seen.
Oh, thank you.
It's an
Yeah.
awesome logo. So I'd encourage people to go and check out your website. Anything else that I didn't ask that you think would be worth ending on?
No, I just think anyone who's listening or anyone that's interested, really a quick phone call, we could really come up with some high level numbers. So happy to really educate as much as I can and field as many questions from either owners, consultants. They want to put a team together. We can do a Zoom with anyone that's interested. So, I like to keep my guys busy. These are exciting projects. So, we like to really reposition and recycle all these old buildings. So whatever we can do to educate and answer questions, we're certainly open to. So thank you for putting this together for us, Chad, and letting us give our little spiel.
Yeah, I've been doing this for 18 years, and I had no idea that this, like I said, was an affordable option. So I've learned a lot from this. I'm really grateful that you took the time to come on this
Yeah.
and help people out. So I'd encourage you to anyone considering raising a roof or seeing a property that has that limitation to reach out to Marty. And once again, Marty, really do appreciate you coming on. And for anyone watching, please give us a thumbs up if you liked it, or a thumbs up if you didn't like it. We like all types of feedback around here. So thanks again for watching, Marty. Once again, thanks again for being on the show.
Got it. Thanks, Chad.
Okay.
Talk
Thanks,
soon.
everyone.